Welcome to the lesson number 6. The lesson number 6 in this module is chromatographic techniques. Chromatographic techniques is a method in which we separate the compounds which are present in a sample. Chromatographic techniques has been used from the very older times. Right now we are having specific instruments, sophisticated instruments for performing chromatographic techniques. In this chapter, we are going to give you a basic introduction about what chromatographic analysis is and how it is important in the pharmaceutical industry. So let us start the video. Lesson number 6, chromatographic techniques. So dear students, in this chapter we will learn about chromatography. So chromatography is a very powerful analytical technique. It's a very important technique. It is a method of separation. Particularly, it is a physical method of separation. And this method of separation is used to identify the components in a mixture. What we do here is, in a sample, we are having, say, compound A, compound B, and compound C. When we will subject it to chromatography, then what will happen is A, B, and C will become separated from each other, and A, B, and C can be identified by calculating their RF values. This is the general technique to separate and identify through chromatography. So please understand my words that when I am talking about chromatography, chromatography involves first separation of the components and then identification. So it is initially a qualitative analysis. It was a kind of qualitative analysis. But now, as new modern methods have been arrived, we have also converted into quantitative analysis. That means you not only separate and identify the mixture, but you also check the amount of that component in the mixture. So you can also do the qualitative and quantitative analysis. So in pharmaceutical industry, chromatographic methods are very important. They are very important. They are most widely used. Almost every pharmaceutical industry uses this chromatographic technique. These chromatographic techniques are used basically for the quality control and for the analysis of pharmaceutical substances. Now coming to the basics of chromatography, we should understand the basics first. See, chromatography is actually made up of two words. Number one is chromatos and second is graphos. Chromatos means chroma. Chroma means color, or graphos means writing. So chromatography is basically color writing. This was first discovered by Michael Sweat, in which he separated plant pigments by performing column chromatography. There was glass column. It was a cylindrical tube in which the solid phase was kept and the plant pigments were separated, and they were separated on the basis of their color. So this technique was first developed. Now, as you can see the principle that chromatography involves separation of the components, and this separation, it depends on the interaction with stationary phase and the mobile phase. Let us understand in depth. See, what we are having in chromatography, there are two phases. First is stationary phase, which is not moving, it is stationary, it is kept still, and another is mobile phase, which is moving. So what we do is that we are having stationary phase like this, and the compound, the sample to be separated, is lodged onto the stationary phase. This is our stationary phase. Now what we do is that We run mobile phase from above. Mobile phase will sweep away these components, and there will be an interaction between the components. Say there are three components A, B and C, and let's just say AB has more affinity with the mobile phase than with the stationary phase. So mobile phase will carry away A to the longer distance and A will be separated from B and C. And let us assume that B is having a little less affinity with the mobile phase than in comparison to that of A, but it is more affinity, it has more affinity with the stationary phase than A. So it will be separated in the next, and the last, for example C, let us say C is having the least affinity with the mobile phase but the strongest affinity with the stationary phase. So C will stay here at the starting point. So the basic concept is very simple, that the components of these mixture are separated by the mobile phase, and that depends upon the affinity of these components with the stationary phase and the mobile phase. If the compound to be separated has more affinity with the stationary phase, then it will be the last one to elute. It will come out in the last. And if the component is having least affinity with the stationary phase, it will carried away by the mobile phase and it will elute first. You can also say that if a compound has more affinity with the stationary phase, it should have the least affinity with the mobile phase, or if it is having the least affinity with the stationary phase, it is having more affinity, the highest affinity with the mobile phase. And that's how the components are separated. The basic principle in all kind of chromatography is same. The stationary phase here that we use in chromatography, it can be liquid, it can be solid, okay, and solid, like it can be silica gel G, or silica gel, or alumina. It can also be paper in case of paper chromatography, okay. Now, so the stationary phase can be solid. Most of the time it is solid. It can also be liquid and gas. Now, high performance liquid chromatography. High performance liquid chromatography is a modern technique. It is a very important technique. It is a modern technique in which we do the chromatography, but the mobile phase is run at 150 times more pressure than the atmospheric pressure. So in HPLC, the pressure is very high. There are very small columns in which the compound to be separated is run, the sample is run, but under high pressure. So it utilizes liquid mobile phase and a solid stationary phase, and the resolution, the separation is very high precision. It is basically, this method is used in pharmaceutical analysis for separation and also for quantification of compounds in the liquid samples. Now gas chromatography is also the modern technique. It is basically used for the volatile compounds. The basic principles of separation is same. There is a stationary phase in which compound is kept, and there is a gaseous mobile phase. The gas is passed from the stationary phase and it will carry away all the volatile components. So it is ideal for analyzing the volatile compound like drug metabolites or volatile organic impurities. Now in thin layer chromatography, it is also a very commonly used technique. In particular organic chemistry, this technique is used for the reaction monitoring. a very important technique, a classical technique of chromatography. So there will be a thin layer of adsorbent material as a stationary phase like silica gel, alumina. Most of the time we use silica gel G, and on which we run a liquid mobile phase. The mobile phase will be liquid and the compounds are separated on that silica gel plate. Now this technique is very quick, it is cost effective also, and in the early stage of drug development we typically use this technique. Now what are the key parameters in chromatography? There are some important terminology that we use in chromatography. The first one is the retention time. See, retention time is the time in which the component spends in the chromatographic system. Let us understand what it is. Say, let us assume that there is a column in which stationary phase is kept. Now we have introduced the sample at the top of this column, and now after some time when we run the mobile phase, our first component A separates out. So the time it takes from moving this point to this point is known as the retention time. This is known as retention time. Now next is resolution. Resolution is ability to separate and distinguish between adjacent peaks. See, suppose that A is separated first, then after that B comes out, and then after C comes out. A good resolution is that in which the peak of A, B and C are clearly separated and clearly visible. Now selectivity. Selectivity is the degree to which a method can differentiate between the components. See, for example, GC has selectivity for volatile compounds, but HPLC can be used for non-volatile compounds. So GC is selective for the volatile ones while HPLC is selective for non-volatile ones. So this is what selectivity means. Now a very important point is the retention factor, RF value. RF value is nothing but it is mostly taken in TLC. You study in TLC. See, this is our stationary phase in which this was our spot. Now as the liquid run, our spots travel from this first initial point to this point. So let us assume that this point is 1 and this point is 2. But this spot run along with the mobile phase, and let's say the mobile phase goes up to this point, and along with this is the point where mobile phase runs, and this is the point where our component goes with the mobile phase. Now let us say this distance is x from the beginning, and this distance where mobile phase is run, say this is y. Now the RF value is distance traveled by the analyte, which is x, divided by distance traveled by the mobile phase, which is y. So this RF value is always less than 1, because if it is equal to 1, that it will mean that mobile phase and the spot has run to the same distance. That is not very much informative. So it is always less than 1. It is a very important technique, and this method and this RF value can be used to identify the compounds. So this RF value gives us the qualitative analysis of certain compounds. Now talking about the applications in pharmaceutical analysis. So what are the applications of chromatography in pharmaceutical analysis? Now we use it for identification and also for quantification of APIs. APIs stand for active pharmaceutical ingredient. Identification, simply the qualitative analysis, and quantification, simply the quantitative analysis. As I have told earlier that identification was used in the classical method, but now we are having modern methods which can also be used for the quantitative analysis. Now we also perform the analysis of the impurities and the degradation products in drug formulation. Say if there are degradation product or if there are impurities, they can also be identified through the help of chromatography. And this method is very important in the quality control in the pharmaceutical manufacturing process. Now there are advances in the chromatography field. Advances in terms of the instrument that we are using now. Instruments which we use now are very sophisticated. They are having high selectivity. They are also very powerful. They are very high. They have very high resolution. Their sensitivity is very strong, and they are able to identify very small amount of impurity, and they are also faster. So in this order, we are having UHPLC. It is an upgraded version of HPLC. It is ultra high performance liquid chromatography. Obviously, this instrument will be having higher efficiency and faster separation, and they will work faster than HPLC. Now, we can also combine two different techniques with each other, like we are combining here GC, gas chromatography, with MS, mass spectrometry. So what we are doing is, let us say we are having some volatile compound, and we are separating it by gas chromatography, and say we are having three compounds to be separated, A, B and C. Now GC will separate these three volatile compounds in the sample, but MS, that means mass spectrometry, as I have told you in the earlier videos, that it is used to identify the molecular weight. So mass spectrometry will identify the molecular weight of A, the molecular mass of B and the molecular mass of C. So these are the two different techniques which are combined. You can combine HPLC also with MS, so that becomes LCMS. We have combined GC with MS, so it becomes GCMS. And this will help by combining it with MS, mass spectrometry. This helps us to identify the peaks also. So these techniques are very important and most frequently, most widely used. Now chapter is completed. Let us consider the summary. Now you have studied that chromatographic techniques are very fundamental in pharmaceutical analysis, very important. Few techniques like HPLC, GC and TLC, they are widely used. Point to be mentioned here is HPLC and GC are in the modern techniques and TLC is a classical technique, but they are frequently used. You have also learned the key parameters like retention time, resolution. These terms are very important, and one, as an undergraduate student, you must know what that is. You've also understood the application of chromatography in API analysis, impurity detection and the quality control in pharmaceuticals. Thank you. So dear students, I hope you have understood the whole chapter, and chromatographic techniques are very important techniques. They have importance in the previous time as well as in the modern days. Previous time you have seen that we used them manually, but now we are taking the help of instruments to perform chromatographic analysis. So our next chapter will be on the spectroscopic methods. These methods are used in modern days in the industries as well as in the research institutes. So let's meet on the next chapter, next video. Till then, goodbye. Thank you.